So complement, we are on record now. Let's take Odum Benjamin to give us his first comment on what he saw in the Unit 7. And then we'll take it from there. Go ahead, Odum.
Madam, from the look of the Unit 7, I saw, how do you call it? Inductive reasoning in the sciences and everyday life. And you were talking that the science there is, how do you call it? The science there is an empirical science, which means that it studies, how do you call it? Which means the studies that depend on observation, gathering of data about senses to do their work.
Very good. It's a good start. So we are going to interrogate how the empirical scientist reasons from his premises to the conclusion. Unit 7 is not doing deduction. Unit 7 is doing induction. Induction. We focus so much on deductive patterns in the Unit 6, where we did the modus ponens and co. But Unit 7 is looking at how we reason inductively. Well done. Right, Siauna, please, what did you see?
Yeah, madam, please. I saw that we will be talking about induction arguments, but focusing mainly on the enumerative type of inductive arguments. Yeah, please, that's what I saw.
Thank you. Jonathan, John Tete, please tell us what you saw. We are all listening. Thank you.
Yes, madam. Please. What I saw was that we saw.
John, you may have to kindly move around a little so that your reception will be clearer. Okay. John, kindly move around just a little bit more. You have a clearer reception that will take you again. Okay, I've muted you for now. Okay. Kobe Wills, tell us what you saw, please.
Oh, okay, Doc. When what I noticed is when we're doing the induction versus deduction versus induction, we said that inductive argument, if the premises are true, then the conclusion is also necessarily true already. But when we come to the induction, it also says something that I don't really. It said when the note aspect, he said conclusion may be false, even if it assumes that the premises are true and no contradiction will be created. So I wanted you to throw more light.
There's no light to throw on it, Kobe. I threw a lot of light when I discussed the distinction between deduction and induction, even before launching into the patterns, the valid patterns. Okay. So as for the distinction between, yes, thank you, sir. The distinction between deduction and induction, I think the class should engage the content on that. Engage it. I mean, if this to the class now, Kobe, don't worry. If it wasn't clear to you, then it's very problematic, because if we don't understand what's the other one, induction very well, then you struggle with deduction. So what we would have done would not be effective. Deductive patterns, whether modus ponens, tolerance, hypothetical syllogism, disjunctive syllogism, are saying that if the premises are true, it would require necessarily that the conclusion must also be true. Then we contrasted that with another pattern of reasoning where it is possible for all the premises to be assumed to be true, and yet the conclusion does not have to be necessarily true with it. That is the first distinction established before we even launched into the reasoning patterns for the deductive forms. Okay, so if you recall, we put there an example, and I think they will all be repeated here. just so that we set you up well and then take off into the next topics connected to that. I'm trying to show you that if you don't, I'm down to the class, okay? If you don't do your preparation well and you build on a very weak foundation, your building will collapse. And we don't want the building to collapse. We want you to do very well. Most politicians are corrupt. Nancy is a politician, therefore she's corrupt. That is a typical example of the pattern I gave to show induction, where you can still, as you said, most Ghanaians are hospitable. My mother is a Ghanaian, therefore she's hospitable. I mean, this is commonplace. Look at all our slides. It's there. The reason why such a reasoning will be considered inductive is because it is possible for us to accept all the premises given as true, and yet it will not require of us necessarily to accept the conclusion also. This is central. It's not something we have to beat about the bush about, okay? All right, let's take Nanama Asumedu. Tell us what you saw in the raw slides I gave you. Just raw slides, not your understanding of it. But you saw something put down in the slides, notes, your textbook also for Unit 7. I'm listening, my lady.
Please, so from the slide, I learned that in inductive arguments, you still have premises and conclusions. But here, the premises that not, although there are premises, it doesn't mean that the conclusion will be true, will necessarily be true. It doesn't guarantee that the conclusion will be true.
Very good. Can I ask the class what the types of inductive argument are? Any type of, mention any type of inductive argument you know of. Anybody at all? So maybe I take Emmanuel Kofi Dubate. That is if Emmanuel is able to answer that for us. Emmanuel, any type of inductive argument. If I said a type of deductive argument, then you would say modus ponens, modus tollens, etc. But I'm asking for any type of inductive argument. Dubate, are you able to? Ziggy? If Dubate is able to, please go ahead quickly. Don't waste the time. You will need it to. If our brother is not able to, let's take Dinah Ifua Adoma. Dina, go ahead. Oh, Dora Sechua Ochre. Can you help us with that? Any type at all? You see how? Okay, let me just. Diana, can you hear me? Any type of inductive argument?
Yes, dog.
Kind of law-like hypothesis.
No, that is not a type, please.
It's a type of inductive arguments. We have enumerative and enumerative type of inductive argument, and also analogy.
Very good. Very good. Well done. All right. Now let me see. So
my hand is up for the types.
Oh, it has been answered. Thank you, my brother. Okay, it has been answered. So we move on now. Very good. I just want to caution everyone and to keep encouraging you. Please, when we give you the content, it is in your own interest to just go through it. Would they go through it, Keke? Eh? At least the raw slides. Then check it against your textbook if you have it, and you should, and fill in the gap. So when we meet, it is the technicality of it that the lecture is supposed to help you see. So it brings understanding, maybe to help you see the practical relevance, then to help you construct, reasoning around that. That is what lectures are for in every course in the university. It is not at the lecture that I come to tell you 2 parts of this or 2 types of that, or no, that one doesn't help you. Okay, so I hope that generally we are doing fine. We will go quickly through the slides. Everything I'm going to say it's already recorded. I gave you a recorded lecture, so we wouldn't have had need to meet like this. But the meeting is to help you understand it. Otherwise, it becomes repetitive. So you have recordings in the resource tool, uninterrupted. Then we come and hold a whole lecture on it again. That one also added to your slides, to the textbook for just 1 unit. You see, it can be very stressful if you are doing your part very well. Then this will just be okay. So with pardon, okay, doc, please, the confirmable. If you could just throw some like, why is it that the empirical content for this and the pseudo precision has done the, you see, then the lecturer is throwing light and then going through the slides and showing you, see that I said this here. Okay, I meant this, and that is why it's this. That's how you learn. You will progress faster and well. But this spoon feeding posturing, generally speaking, maybe not to the class, that would not help you. Okay, so what should you know in Unit 7? You should know what inductive reasoning is. It is inductive reasoning in the sciences and everyday life. The focus is not deductive science. The reason is that some people think of mathematics and logic also as sciences, insofar as they are investigating to gather knowledge. It is a science in that sense of it. But we are not dealing with that kind of science, that connotation of the word science. We are dealing with the empirical studies. Science labeled as what? Empirical studies. What is empirical? Observation based. Okay, so you gather data by observation, then you draw your generalizations from that. That is the kind of scientific enterprise we're focusing on. And we are looking at how the sciences operate to reason and come out with their findings and their conclusions, if you like, quote and unquote. We will focus, we will also remind ourselves of what? Verifiability, look on your screen, and confirmability. These are technical words. So it's not a straightforward matter. You have to be helped to see it. But note that when we say a statement is verifiable, it doesn't mean the same when we say the other statement is also confirmable. Confirmability and verifiability are not the same. They deal with a different type of statement in the reasoning pattern of what? Empirical scientists. We want you to also note enumerative induction. It's a type of induction. Just like modus ponens is a type of deduction. Enumerative induction is a type. What's the other one? Analogy, your friend said it. Argument based on analogy is another. Argument based on sampling. When you sample a few, draw a conclusion about it, and then impose that conclusion on the whole. I mean, when we go to hospital and they want to check our blood, whether there is a certain infection or not, they don't pull out the whole blood in your system. They just take a certain drop of it. But whatever is true of that sample, the assumption is that it is true of the whole system. Okay, and the point then is that there are certain places a sample may help you arrive at what? The truth or falsity about the whole population of that group. But for other places or other circumstances or other sciences, it may not work, like political science. You can do just a subset of Ghana, get some few people and interview them and find out what they think of, say, a certain politician. And then you conclude that therefore what the few people said, the sample said, will necessarily represent the whole. Not necessarily. That's why people say we are in a comfortable lead, and it might turn out to be false. They didn't say it out of the blues. They did some research, but the outcomes and the analysis and the imposition of what is true of the sample onto the whole could generate a certain hiccup here and there. So we will learn the types of what? Inductive argument. But for this semester,
your line is breaking. Can't hear.
for this semester, please, is this a general issue or is my lady that cannot hear me, please?
You can hear you,
Because I'm in
madam.
the-
Okay,
I can hear you.
it's okay
I
for
can hear
me.
you clearly.
I would love it. I always caution students. I think it's good when you
Thank
send in
you.
the prompt. Thank you very much. When you send in prompts, it's fair, okay, because you cannot hear. So it's fair to tell us so that we know. But I don't like general claims. We are critical thinkers. So we are helping ourselves. Say, Doc, please, I cannot hear you. I cannot hear you is not your line is breaking. You see the difference? I'm just saying so that it helps us as we communicate. If I say, I cannot hear you, it helps all of us to adjust. So you'll be adjusting and I'll be adjusting, because then we leave room for the possibility that it is either from my end or your end. But if you immediately say you cannot hear me, then it means you are not part of the problem. But you see that your friends can hear. Okay, so let's have that posturing. If I say, I can't hear you, I will say, oh, check your microphone. I'm also checking mine. Or could it be reception? Or maybe I've muted my thing. Then we work at it together. It helps. So my dear lady, please check your setting, possibly your network or data. Maybe the bandwidth is not strong enough or big enough. I don't know. Okay, check it and let's see. However, be at peace also. Even if you are getting overly stressed, we are recording. We'll share the link in addition to the already recorded lecture. Okay, so my friends, I was saying that in this discussion, we'll focus on specific types of what? Inductive argument. We will not do the others. So your unit 8, for example, in your textbook, which discusses argument based on sampling and analogy, will not be included in our discussions because we will not examine you on unit 8. Okay, so you are doing unit 7, which is currently what we are doing now, the general discussion on inductive reasoning, empirical content, predictive power, verifiability, confirmability, pseudo-scientific statement, and stuff like that. Testability, we'll look at those. Then we will not do argument based on sampling and analogy and jump to unit 9, which focuses on what? Causal reasoning, cause and effect reasoning. So enumerative induction will feature prominently, will be a type of induction that we will look at, and so you'll be examined on. And then the other one will be what? Causal reasoning. Cause and effect based reasoning are also considered what? Inductive, because we are not able to establish necessary causal connection between two events, the antecedent, supposed antecedent condition, and the consequent, the effect of it. We are not always able to establish a necessary connection between the two. Therefore, any reasoning that is based on cause and effect, my dear friends, would have a certain degree of what? Probability, not necessarily a certainty associated with it. Okay, like, I mean, people say that, for example, let me give a very funny example. Someone comes to the office and maybe he says something, oh, you stop disturbing me, why you people like me, and he's angry. So you feel that maybe it's because of what the lady said to him, that's why. And it could be that it has nothing to do with his colleague. The cause for his outbursts may not necessarily be as a result of the sister's interaction with him in the office. He may be angry from home, you see, or maybe the school fees issues have come up. He has school fees to pay, the children's school fees have come up, and he's already in a bad mood. Or perhaps his salary didn't go as he expected. So there could be several antecedent conditions that lead to a certain effect. That's why when we reason based on cause and effect, we think of it as what? An induced conclusion, induction. Then enumerative induction basically is where you list, you enumerate several instances that corroborate the conclusion you are drawing. So it gives good reason to believe that the more evidences you have, see how I'm speaking, then the higher the likelihood that the conclusion you've drawn is true. If it were true that Nancy is a woman and she cheated, Ajwa is a woman, she also cheated, Kojo is Mansa is a woman, she cheated, Zainab is a woman, she also cheated. See what I'm doing? I'm enumerating, giving several supporting evidences of what? Particular instances of women who cheated. Then it will make sense to conclude, listen, that it is highly likely then that women cheat. I haven't proven it because it could be that we will encounter one possible woman who will not cheat. And perhaps we have already done so. So that can negate all the several instances of evidences that we have enumerated and put down. That is the reason why we cannot say, therefore, we have proven, look at the language, we cannot say we have proven that women are cheat. And if you ask me what reasons I have, what evidence, what premises ground, what I'm saying, then I tell you I have several instances. Oh, many than chair, the way fake, so you are listing several. Oh, besides you them, is you crowd them not sister is crowd, we cheating, is cheating, therefore. I just repeated what I said earlier in English. If all I'm doing is giving several supportive evidences, I am counting, see that? Counting several particular instances that support, that corroborate, that agrees with the conclusion that I'm drawing. See, when we go ahead, you see that we don't even use conclusion, because it's not conclusions, it's not concluded, finito, no, no. It's still subject to further study, that conclusion I've drawn. Why? Because I'm moving from several particular instances, and then I conclude that therefore all women are cheat. We say that therefore all women are cheat. It's a hypothetical statement, it's a hypothesis. It's a generalization that you have drawn on the basis of what? Several particular enumerative evidences. That kind of reasoning pattern is what we call enumerative induction. Then I showed you the causal reasoning based inductive argument. Okay, so those two will be prominent subsequently. Unit 9 will do with causal reasoning. So for your IA, you don't need that. But for your final exam, Unit 9 will come in, and then Unit 10, the informal fallacies, errors that we find wrong in the reasoning. We'll top it up. Then you have a very nice, well expanded, if you like, view of critical thinking. Okay, so the first 3 units that we've done so far engaged what? Language. Then the Unit 5 and 6, no, the Unit 5 dealt with what? Scientific laws and the various connotations that we can give to the word laws. Then we moved to Unit 6, we dealt with what? Reasoning, but reasoning what? Deductively. Then we continued with what we are doing now, inductive reasoning, which is what? Reasoning inductively from empirical science. Now, if you saw enumerative induction, and then you also understood law-like and statistical hypothesis, then we should be very okay. So on the screen now, you will see that you've seen all these. All these were in the discussion in Unit 6 when we're doing deduction, because we needed it to establish the contrast between the two before building on the deduction. Okay, so I put here recall. Recall means it's just for you to remember something that we've done already. I want a very good reader to quickly read through it. I wasn't expecting a very long video today. So Nafis, if you can do as your honest, you kindly read the record.
Let me read, madam.
Is it Guru?
Yes, please.
Guru, go ahead then. Thank you.
Unlike deduction in inductive argument, the premises provide some reasons and evidences to believe the conclusion will be probably true, not certain, in bracket.
Good.
Also, the premises do not prove or guarantee the truth of conclusion. That is, no logical relationship between the premises and the conclusion.
Very good.
Also, the conclusion does not necessarily follow from the premises. And then the meanings of the content or the information provided the matters in confirming the degree of likelihood of truth of conclusion based on the strength of the evidence presented.
Excellent. So I just wanted to point out quickly to everyone that you want to look out for the key words. Some of them have been italicized. I put them in italics for emphasis. Okay. So even if we assume the premises to be true for an inductive argument, a good one at that, we will not have proven it. The language proof won't work. It is just a matter of probability. Then perhaps what we would have done if we gave good evidence supporting the claim we are drawing, the conclusion we are drawing, if we have done well with this, like if I said most Ghanaians like pineapple, and my friend is a Ghanaian, so I believe that she would also like pineapple. This is highly probable because I said most. You see, most is the evidence I've provided. If I said most, and then she's also like them, Ghanaians, then the chances, the probability, the likelihood that my friend would also like pineapple is high. So we will say it, you have confirmed what? The degree of likelihood of truth. I haven't proven, friends. Check it, okay? So the strength of the evidence is measured by the content or information, the subject matter. Unlike when we're doing deduction, where we're just concerned by what? The raw pattern of thought. This is very important for us. So the conclusion may even be false if we were to assume that the premises were true at all, and there will be no contradiction created. This is why when that reasoning will be called what? Induction. Very good. Guru, please go ahead. Guru,
Okay.
please go ahead.
Okay. The more evidence you have that corroborates, that support the conclusion, the higher the degree of confirmation. But confirmation is not proof. Also, the type of inductive argument, that is argument based on sampling, analogy, causal reasoning, enumerative induction.
Very good. So the word is causal, from the word cause, to cause something. C-A-U.
Causal.
Causal. Yes, sir.
Okay.
It's likely you may find questions. I don't know which question will get to who, but students sometimes overlook that. This is not casual. This is causal. Okay. All right.
Causal,
then what our brother read, yes, Guru told us, friends, that confirmation is not proof. If I have confirmed a certain claim, it only means that I have added to the evidence that supports the conclusion that I drew. So if I say tin is a metal and it expanded when heated, bronze is a metal, it expanded when heated. What's the other one? Brass is a metal, also expanded when heated. Copper is, and I'm listing and listing and listing. The more, therefore, I conclude, therefore, all metals expand when heated. Now, the more evidence I have of particular instances of metals that expand when heated, the higher the degree of likelihood that my claim all metals expand when heated is true. It only makes it highly likely, highly probable. The chances are high. But we all know that probability is never equal to 1. There's never a certainty with a probability. It might be 99.99999999999% true. It is still not 100% true. Therefore, if I claim that I've confirmed it, I've only increased the likelihood. I have never proven it. It's the language we are concerned about. Because if it's a proof, then it cannot be false again. Then we shouldn't go looking for any research on it. But because potentially it is possible that our findings, which findings are we referring to? Empirical, the observation-based. If the observation-based finding is presented as if it is a proof, we have a big problem. Then when the HIV researcher says that I think I have chanced on what? A cure for it, no one will even give them ear. If someone said, I think I have a cure for monkeypox, not a vaccine, a cure, no one will listen, because if we work with proofs, it can't be otherwise. So no one can have an alternative view. But empirical science cannot have that posture. And some of us are a little bit passionate about it because you are only discovering what has been put there. You didn't create the world. You didn't. So your posturing must be right if you are doing empirical study. If you are doing deductive studies, we are dealing with a different kind of study. There, we prescribe how things must be done. So this is mathematics. 2 + 3 must be 5. Remember the senses of laws we learned in Unit 5. So we dictate to ourselves in that discipline how we will add. That's why it can't be otherwise. Then you can say when you go to Rome, you do what the Romans do. Remember the 6 senses of the word law, okay? But when you're doing a description of what is there, it is what you observe that you write down. So when you go and the observation changes, you come and change it. A meteorologist, you can't do deduction with that kind of approach of study. Of course, there might be aspects of the study that are closed, that are deductive, but we are talking about the trusts of that study. It's an empirical study. So the empirical scientists could tell you to rain tomorrow heavily based on X, Y, and Z observation, and that day it will rain. I jokingly tell students all the time, God will play 6 miludu And when it goes 6, it says, okay, today I've changed my mind. So all that you knew about the world might go wrong from observation. That's why you must always be open to possibilities of what? Either confirmation or what? Falsification. So your theories, general claims in empirical study are subject to further study. That's why they are called hypotheses. So that they claim all metals expand when heated is itself subject to further study. It is not conclusive, it is hypothetical. And so you and I know that as we speak now, that statement is not true. It has been falsified. Some metals do not expand when heated. They are the ones that you and I, you ladies, fine ladies, we want for our earrings. We want for our gold, we want to wear on our rings, because then when you take it near fire or you even leave it there, it will not expand and lose its shape and what have you. So the more we allow for research, it will suggest then that we cannot claim conclusive, proven claims of what? Scientific statement. I don't know how to say it. I just hope that I didn't end up talking too much, but that's the point. So if you have a friend read it, Guru read it nicely, I put it back. If I told you confirmation is not proof, look at the several examples I've given. You should be able to illustrate that, show why the empirical scientist cannot think of confirmed claims as what? Proven claims. If you got that, then we move on quickly. So some examples on the screen to help you. We saw inductive reasoning already. So these are just examples, just showing you, and I point you to some pages in your textbook to help your revision, okay? If I said 80% of politicians are lawyers, Mr. Kofi is a politician. So I conclude, therefore, he's a lawyer. The reasoning here is induced. The conclusion you are drawing is induced from the evidence. It's possible for us to accept, for example, that 80% of politicians are lawyers. And then we also accept that Mr. Kofi is a politician. And even if these two premises were true, it would not mean necessarily that so he's a lawyer. We know that now, okay? Few Ghanaians are hostile to foreigners, and stuff like that. All these are examples to help. We don't need to waste too much time. So 2 out of 5 women like rich men. So I conclude that women like rich men. Well, 2 out of 5 women, let's assume that that is true, like rich men. Does it then mean that women like rich men? Necessarily? Look at this is women. Oh, this is women. And this is 2 out of 5. Someone said hello. Is it Odum? Emmanuel Etona. Someone said hello. I just hope that the person asking a question, Anita Mpoma, Mary Hene Damwa, these are the hands I see here. Okay, if it's not a question, then it's fine. Let's move on. So I was just saying that all these instances, if I said 2 out of 5 women like rich men. So I conclude, therefore, that women like rich men. Women like rich men. It's like saying all women like rich men. So you tell us all women like rich men, and we ask you for your reason for saying that. You say, oh, but 2 out of 5 women like rich men. You are saying 2 out of 5. Okay. You are saying 2 out of 5. Then I cannot make this conclusion. Okay. Deductively, it is not a deductive conclusion. Right. So we can move on now to some examples. On your screen now, and in the recorded lecture for this unit, you will see this example. I've already used it more than 17 times. I dated Amma, she cheated. I dated Ya, Mansa, Afi. See how the person is listening. And mad son or what? That is how women are. That's the conclusion the person is making, drawing. So all women are cheat. As for women, it be so then they. This is what the person is saying. Then we ask, what is your reason? He said, oh, but I dated Amma. She cheated. Ya too did the same. Mansa, she cheated. Afi. So you see different particular instances, watch, of evidences. You see the word I'm using now? Premises, reasons. When you are using them in empirical study, you want to rather talk of them as what? Evidences. The terminology slightly different, referencing the same thing. They are evidential statements. Your textbook gives you several labels for that. Data, observation statement, stuff like that. All of them dealing with what? The particularity of this statement. I dated Amma, specific, Amma, countable, Amma. Okay, yeah, countable, direct. You can finish counting, you can test directly. You can put CCTV camera in Amma's room to check if she's cheating because she's particular. So several particular instances like this. Then the person concludes, look at even this one, what I'm highlighting now. All the women I have dated cheated. This is still particular. We'll see in a minute. All the women, the definite article, the. So all the women I have dated cheated. This is still a particular statement. It's verifiable. Oh yes. Directly testable. Those who have read ahead, you see that things are falling into place for you now. Yes, all the women in this class got A's. All the gentlemen in this class got A. It is particular. I'm referring to specific, countable, finite reference class. Okay. But where there's a problem is the person's conclusion proper. Okay, look on the screen. So from all these premises, the gentleman concludes, the conclusion is in blue. So all women are cheats. Look, all women are cheats versus all the women are cheats are not the same statement. Critical thinker, hello, you want to be careful when you are drawing universal generalizations as your conclusions based on the evidences that you have. We don't care how many evidences you have. You may have 100 particular instances. You may even have 1 million particular instances. If on that basis you conclude that all women are cheats, we may say, well, you have a very good reason, probability, high degree of likelihood, but we can never say that you have therefore proven. Proof is a problem. You cannot say that science has proven that, and what you are showing is not a falsification, but rather a confirmation. No, confirmation is not proof. So see the summary down here. We say the premises are verifiable statements that are listed or enumerated to show the several instances that support the generalized conclusion or hypothesis. Note that the hypothesis is not verifiable, but it's only what? Confirmable. Very good. So you will see that there will be then two kinds of what? Enumerative induction. In other words, you can do enumerative induction in two ways. The difference comes in how you are concluding. In one instance, you can conclude with a law-like hypothesis. Law-like meaning the reference class there doesn't make any exception. We'll go there in a minute. It's the next slide, okay? Then sometimes you could conclude with a statistical hypothesis. That is a conclusion that is general, yes, so it's a hypothesis, but then it leaves some of the reference out. So if I say most Ghanaians are hospitable, I just made a statistical generalization. Most Ghanaians. Most Ghanaians doesn't mean all Ghanaians, see. But Ghanaians is a general statement. Ghanaians of all times, all places, yet to be born, alive, dead, those that are going to die, and those that are going to be given birth to. So when I say Ghanaians, it's a general set. That is why whether it is statistical or law-like, it's a generalization. But with type, where I said all Ghanaians, then it becomes what? A law-like or universal generalization. Where is that? Let me show you. Okay. And then let's go to that slide quickly. I'll come back to where we are now. I want to show you law-like and hyper. So yeah, so here we are on the screen now. When there is no exception to the reference class, which is general, then you call it what? A universal or law-like generalization. And so one of your friends wanted to know, Doc, you didn't go through some of the slides in our unit. I said, my friend, learn as you are being taught. You keep the slides because you find their value at the specific places that you need them. So you don't do redundancy when you are studying. You don't study without pattern or plan. Okay, so this is where you need it very well. Now, universal generalizations are also called what? Law-like generalizations. They are like laws. Laws do not leave anybody out. The law applies to everybody. The law is no respecter of persons. So when I say men are bullies, it means I'm saying all men are bullies. I left no one out in this reference class, men. So this is a universal generalization. Universal applies everywhere, applies to all. Okay, universal generalization, law-like generalization. This is a typical example. Why is it a generalization? I said men. I didn't qualify. I didn't say that man, these men, the man sitting under the tree, those men in that building. No, I didn't say that. There would have been particular, countable, verifiable, you see. But I said men are bullies. So this is a universal or law-like generalization. Then the second example that I said some men, the reference class is still men. Oh. So it's a generalization. It doesn't exempt, how do I say it? It doesn't, the set is general. What helps us to distinguish this one though from the earlier one is that here I said some men. So the general reference class is there, but I have exempted some members in the general set. Okay, so I say some men, most men, 2 out of 3 men.
Which is confirmable, dog.
So then it becomes a statistical
confirmable
generalization. Yes, we'll go there in a minute. Yes. So the general statements are confirmable, whereas the particular statement or the verifiable statement, whereas the particular statement are verifiable. Very good. We've gone ahead. Very good. Now, so I want to take us back to the 2 types of hypothesis or the hypothetical state. I'm just trying to simplify things for you so that you get the connections. Okay. So look at here, we're here, enumerative induction 1, then enumerative induction 2. How do you distinguish between 2 ways of reasoning what enumeratively? You could do enumerative induction where you count your evidences to come to the conclusion. See, but that conclusion will be a law-like one, making no exceptions to the general set. Then you could also reason in a way, enumerative induction still, but your conclusion is a statistical hypothesis. So from, look at what we did earlier, see this one. From I dated Amma, she cheated. I dated Ya, she cheated. Mansa also cheated. Afi, Zainab. The person concludes, look at the conclusion, all women are cheats. This is not likely to be true because of the all women. The evidences may be true, but they don't support your conclusion, all women. See, this will be likely to be false, this reasoning pattern, compared, there we go, compared to this other one, okay, which says, oh, still let's say a law-like one. I want the one that is compared to this other one on our screen now, which says, I dated Amma, she cheated. I dated Ya, she also cheated. I dated Mansa, she cheated. Afi also cheated. Zainab cheated just yesterday. Therefore, see the conclusion, not the summary, but the conclusion in blue. The person says, so most women are cheats. Now you see that if I compare this conclusion, so most women are cheats, with the earlier one which said, so all women are cheats, from the same evidences. The current slide, which had a statistical hypothesis as its finding, as its conclusion, you see, will be more likely to be true than the other one, which is concluding with what? All women are cheats. We will say that, oh, my brother, but even if all these particular instances were true, you still can't conclude, therefore, that all women, because we can have just one woman who is not a cheat, and it will make your conclusion false. Okay, so the one that concludes with this statistical hypothesis is highly probable. It has a greater degree of truth than the one that concludes with what? A universal hypothesis. But you'll be amazed, like I said in the lecture, that this one, which is more likely to be true, that's the one that ends with a statistical hypothesis, is not as valuable to the empirical scientist as the one, rather, that is likely to be false. Really? Yes, statistical hypothesis is more probably true than what? The universal hypothesis or law-like hypothesis. See that? One is saying, but you will be shocked that the one that is more likely to be true, this is the statistical hypothesis, doesn't have as much value as the one that is what? More likely to be false. for the scientists, if I do empirical science there, now are they crazy or something? No, it is because of what science aims at doing. So falsifiability is a value for scientific study than confirmability. If theories are being confirmed and confirmed and confirmed, it doesn't lead to the kind of joy that the scientist wants compared to if their theories are falsified, and you'll see in a minute. But let's make sure that we have covered good grounds before we add to it. Oh, who is this? So we go through what we've done so far. We go through what we've done so far. I have revised, going from beginning to where we are, gave you the outline. Then I helped you recall induction. Guru helped us go through induction, the types. We stressed that confirmation is not proof. Then we've seen some examples. We've seen some examples of inductive argument. And then we just saw enumerative induction, where the conclusion is a universal statement. And we are building on that to have two kinds of enumerative induction. The one that concludes with a law-like hypothesis, and then the one that concludes with a statistical hypothesis. And we quickly have made a note that if you're an empirical scientist, you will value a law-like hypothesis, which is also called what? A universal hypothesis. You will value that, even though that one rather doesn't give you the degree of confirmability, probability, the degree of truth that you are looking for. You rather value the one that is easier to make false. And we'll see why. Okay. Guru, please read the next slides. These are examples for you. So we'll move quickly to confirmation is not proof. I've said everything there. So you just read through and then move on quickly. Unless there's a question, then I pause and take them. Go ahead, Guru.
Okay, so inductive arguments aim at confirming the given hypothesis, while deductive arguments aim at proving the given conclusion. Yes, so the evidence of an inductive argument only confirms, but it does not prove the truth of hypothesis. Thus, confirmation is not proof. Hypothesis is the same as the conclusion of inductive argument, whether statistical or law-like.
Very good. I've said all of that. Thank you. On the slide now are just repetitions. The reason why sometimes we repeat and say the same thing in different ways is because people learn differently. Yes. So it helps you to see, like your friend asked me, so that is what you mean by confirmable. When we have a hypothetical statement, whether statistical or law-like, we will say that, such a statement can be confirmed. I get it now. Yes. That's how we learn. So on your screen now, you are not seeing anything different from what I've said so far. They've just been summarized, and then we are showing you the connections between them. So if I have a statement that is verifiable, check my language, then it means it is a particular statement. We learn particular. We have revised it today. We are building on it. Then it's a particular statement. How do you know that? Look at the reference class. I'm using the same examples to help you connect quickly with what you saw earlier in Unit 6, and which has been repeated already in this unit. And I'm still using the same for understanding. When you get the concept, then now you can apply. Okay. So that man is a bully. Look at the reference class, the subject. That man, those guys sitting under the tree there, all those who voted. Everyone who cheats is not. If I say everyone who cheats has done so and so, that is not a verifiable statement. I'm speaking for all times, all places. Men are bullies. Metals expand when heated. Anytime the clouds gather, it rains. Whenever prices of goods and services are increased, quantity demanded falls. Economics. We are not talking a direct statement. You are speaking a generalization. That's how the economists will qualify that. Ceteris paribus. Other factors held constant. Because some exceptions could come in, Unit 5. All right. So what then is a verifiable statement? It's a statement whose reference class is countable, or if you like, is finite. Reference class is the subject. If it is a verifiable statement, then it will be a particular statement. That means you can use it as what? Evidence, because you can directly test. I hope you are looking on the screen because I'm pointing as I use the concept to show you the connection. I repeat that. If it is a verifiable statement, it only means that that statement has a finite or countable reference class. And that would mean then that that statement would have been a particular statement, and therefore you can directly test it to ascertain truth or falsity. It can be directly tested. That's why you can use that to go and verify someone. You can use that as an evidence to support a certain conclusion you are drawing. But if that statement itself cannot be directly tested, look at the second one. How can it become an evidence for someone else? That kind of argument will be weak because what you are presenting as your evidence is itself not directly testable. See, indirectly testable statement will be the one that has infinite or uncountable reference class. Potentially, the reference class has members that you can never ever finish counting. If I say politicians like money, look, the expression I put down, I'm speaking like God. Infinity past, infinity present, infinity future. I'm speaking for politicians dead and gone, politicians currently, politicians yet to be born, to grow up and become politicians and die and give birth to their own great-grandchildren who will grow up and become politicians. How can you verify that directly? How? That is not directly testable. Even though it is testable, take note, so it's scientific, but it is tested indirectly. So when you have a general statement, that is where you have a reference class which is infinite, we test it indirectly. How? We can sample out a few, find out something that is true or false about them and impose on the others. And so the more evidence we have that corroborate it, the higher the degree of likelihood. That's what we've gone through earlier. Okay. So what should you take note of? I hope that there's another repetition ahead. Okay. What should you take note of? If you hear verifiable, then it's the same as what? Particular statement. Then it also means what? Finite reference class. Then it also means what? Directly testable. I hope I've not repeated myself. And so you get the connections. However, on the other hand, if you hear confirmable statement, then it means infinite reference class. It means you are dealing with a general statement. It could be statistical or law-like, statistical or universal, okay? And therefore, we say they are what? Indirectly testable. These are concepts, so you have to get it and get them well. Any questions, please? Put up your hand if you have a question. I see 3 hands up. Are they all questions? Odum Benjamin, Emanuela, Etonam, and then Mary Opon. If it's a question.
No, madam.
Okay.
I wanted to read, but it seems like someone is reading.
Yes, Guru is reading. So when Guru gets tired,
yeah,
again.
Guru.
Yes, please. Thank you very much. And he's reading like a guru, so we are we are enjoying him. Okay, let's see if Emmanuel Aitanam is yours to a question, please. Okay, okay. Is there a question, sister? If it's a question, then please ask. My dear, if it's a question, ask, please, quickly, okay, so that we move. I want you to get the concepts and do well for yourselves. All right, so we can take questions later if they come up. Just put up your hand as soon as you have a question. When I come to that page, I'll quickly let you address them. Okay, so here on our screen, we are on slide 12. Slide 12 is only, again, like I told you, repeating for emphasis and for easy connection. Something that you know already that even now we have said. Look at that. I said recall particular versus general statement. So see that man is a bully. These are all from your 6th unit. Slides from there. Reference class. See that. Then we moved on. Universal and particular. Excuse me. Universal or law-like versus statistical. And then here we are. We saw this. We just saw this. I said it's all about the reference class. If you want to tell whether a statement is general or particular, but do keep your thing muted. Why? I've muted, so don't unmute. Your friends are chatting there. It's fine. Let them have their fun, but don't interrupt the class with it. Okay, so particular statements have final reference class. I've said all that. They are directly testable and therefore useful as evidence. We describe such statements as verifiable. I've said it already. Generalizations or general statements have infinite, some say infinite reference class. They are indirectly testable and therefore useful as hypothesis or conclusion. We describe such statements as confirmable statements, okay? And I want you to take note that in all cases, it is the reference class that is doing the job of determining whether a statement is particular or general, confirmable or verifiable, finite or infinite, what's the other thing? Evidence or hypothetical, whether you will use a statement as evidence or not. It's all dependent on the reference class. It's important to know that sometimes we move from statistical hypothesis and conclude with what? A law-like hypothesis, like most women cheat, therefore all women cheat. If I reason that way, I move from most women cheat, statistical hypothesis, and conclude, therefore all women cheat. Our problem is we may accept such a reasoning, but it is so weak because your very evidence is a generalization. The evidence you are coming to use to prove your point is itself, it itself needs what? To be verified. So it will not be a very strong argument inductively. Okay. All right. So I just chipped that in to help you. Now let's see if there's an addition here. Very good. So some practice. And here I want all, I put the answers there. Oh dear. The answers are already there. Don't faint. Let's see if people understand. So we are going to do it together. Practice. I say verifiable versus confirmable statement. Answer my question. Is question 1 particular or general? Look at the question I asked. I said particular or general. I want to see first. Then we can now explain whether it's verifiable or confirmable. So I want a uniform answer from everyone. We'll all answer. The one we finish, we mute. So question 1, the disease is contagious, particular or general?
Particular.
Very good.
Particular.
Yo, it's correct. Let's go to, no problem. Let's go to, I know our networks are not the same, but we'll work at it. Don't worry. So I muted everyone again. Let's go to question 2. Few Ghanaians are allergic to pineapples, particular or general? All of us.
Particular.
General.
Few Ghanaians are allergic to pineapples.
General.
All right, so it's a good time to come in now. I intentionally did that, so I'll get all of you. So you see that it's a split kind of feedback, which is helpful. We are over 200, 240 something. So sometimes you don't want feedback from just 1 or 2 people, and then you assume that that is the atmosphere of the class. So the general feedbacks help. Now, if I say few Ghanaians are allergic to pineapples, I'm referring to Ghanaians of all times, all places, alive, yet to be born, dead, and still counting. We would never end, potentially speaking. That's why it's an infinite statement. It has an infinite reference class. So this one, example 2 on your screen, few Ghanaians are allergic to pineapples. It's a generalization. That's why we'll say it's confirmable, okay? But which type of generalization is it? That is where the difference comes in. I said few Ghanaians. So this is a generalization, but it is a statistical generalization. It's a generalization based on what? The statistics. You break them down. So few Ghanaians is a general statement, yes. Which type? Statistical generalization. But we have already learned that whether it is a statistical generalization or a universal generalization,
Statistical.
we describe it as what? Confirmable. That is where we are now. Let's go to the third one. The liquid in that bowl is poisonous. Is this particular or general? All of us.
Particular.
Very good.
Particular.
So,
Particular.
So yes, you are all correct. Mate. It's okay. Please keep it muted as I've done now. So the point is, if it is particular, I'm reminding you again, if it is particular, then it will be described as verifiable. Then we can use it as what? Evidence to strengthen our hypothesis that we are drawing. Example 4, green tables are scarce these days. Green tables of all times, all places, yet to be discovered. The one that we have already, oh dear. The one that we are now going to create, which will be a green table, all included. That is a generalization, and it is a universal one. Universal. Kofi is the new SRC president. Particular statement. Kofi. So it's verifiable. All voters, look at 6 and 7. I stressed that also in the recorded video sent to you. All voters prefer a recount of ballots. All voters. Even the tree and the GAR translation that recorded. Money for Oshiki. Then you say something about everyone that votes likes, exactly, likes that the ballot be recounted. Okay, that is a general statement. Which type? The universal one, the one we've called law-like. That didn't leave anybody out. So voted those who are going to be born, those in daycare school now, preschool, Montessori preschools now, who are going to grow up and 10 years, then grow again and become 16, grow again, become 18 years before they become voters. They're talking about them. Those who are yet to be born, you and I, our great-grandchildren, who will grow up and start voting, are voters potentially. That's how you are speaking. That's why it's very problematic. Hey, ask for grants, that's like this. Who ask for fancies, they are like this. You, when were you born? How many have you met? Are you God? Critical thinkers will use that. We will see hasty generalization when we get to Unit 10. When you move from few instances and you draw a general conclusion, we criticize you of what? Committing a hasty generalization fallacy. You see it. Okay, now look at 7. All the voters, I'm sure by now you've seen it, interviewed. All the I have a specific countable group of voters in mind. There may be 100 million voters, no problem. I'll finish counting because the way I'm speaking is dealing with a specificity.
Particular.
So it's particular. Then you example 9. No student registers. Please keep your thing muted, I beg you. No student registers unless forced. Now that you know universal negations, if student, then will not register unless forced. But that's not the focus here. This is a universal negation. Now you remember. It's a universal statement. Really? Yep. Yep, it is. So it is not directly testable. It's a hypothetical one. That's why we say, oh, your student there. If he is a student, then something else. It means you haven't established an existential truth. The fellow student amongst you, deductive. But it's not an existential thing, that the thing is there. You are speaking hypothetically. If it were there, then this and this, So it's a universal statement. None of the students in that class, this is just like the 6 and 7, none of the students in that class, this is now particular. And so you know all that is associated with particular. And where we establish that is general, you know all that is connected with general. Now tell me, there comes another one. Oh dear, the class should tell me example 8. No, was it 8? No, it should be example 10 now on your screen. My special student, listen, 80% of all retail stones are not real diamonds. General or particular?
General.
What type of generalization?
General and statistical.
Thank you very much. I said someone is biting me. People may be biting their tongue. Very good, Mate. Statistical generalization. I show people are status. Yes, you just say stat. That's all. As soon as you know it's stat, you know you can conclude in generalization. If it's unique, like university is also a generalization, and we are good to go. These are very important. If you know how to do that distinction, you are finished with unit 7. Really, that's what the unit is about. So depending on how you are speaking and what you are referring to, we are able to tell whether you are dealing with what? A verifiable statement or a confirmable one. On our screen now, I give some examples. And now you know them, so we don't have to waste too much time. See the statistical hypothesis? Americans, see some Americans. Americans is general, but we qualified it with some. This one we've seen already. 80% of all retail stores have done so and so and so. Most Christians worship on Sundays. It's a generalization, Christians, but qualified. So it's most. Okay. Africans, few Africans approve of. If I take off the few and I say Africans approve of same-sex marriage, I'm speaking universal. All of a sudden, yeah. 2 out of every 10 men, look at it very well. Men is a reference class. I qualified it with 2 out of every 10 of them. See that? So this is statistical hypothesis. Now I could have tricked you and look at example 2 and said 80% of all the retail stones in my mother's shop are not real diamonds. 80% of all the retail stones in my mother's shop are not real diamonds. Would that be particular or general? Uniform answer.
Particular.
Very good. So some people should, yes, it will be particular. Well done. So people shouldn't say it because it's all percentage, it means that it is a statistical. No, you are a practical man. Be careful of categories, categorizations, okay? Don't do categorizations that you cannot substantiate. Don't do categorizations that you cannot substantiate. Just know the rule and work with it. So check the reference class. Are they referring to a countable, specific, finite class? Then I'm dealing with a particular statement. Therefore, it will be verifiable. It means I can directly test it, and that is why I am able to use that as evidence. It's a scientific statement of the type that we'll describe as what? Verifiable, finito. On the other hand, if I checked and the reference class is infinite, whether universal affirmative or universal negative, now you see how they are settling it. Yes. Then that statement, whose reference class is infinite, not specific, uncountable, that statement will be called not a verifiable statement, you see, but what? A confirmable one. It means that, yes, it means that it is indirectly testable. I cannot correctly use that type of statement as premises or evidence. It will not be a good argument if I did that. It will be a better, I'll put it to better use if I use it as what? A hypothesis. In other words, the conclusion, which is itself waiting to be what? Further tested. That is what the unit is trying to tell you. Then I put a note here that I want Guru to read. Guru, read a note for me, please, quickly.
Okay, so degree of confirmability, statistical and law-like hypothesis. Example of statistical hypothesis. So 1, some Americans are allergic to pineapples.
Oh, please just read a note, my brother. Okay, thank you. Just read a note to the right side here. Can you see it? I don't know if
Okay.
Because I've read all the others.
Yeah, so,
please go ahead.
Okay, so statistical hypotheses are easier to confirm, therefore less valuable to the empirical scientists compared to the law-like hypothesis.
Very good. I said that earlier. The same thing is what you see on your screen. And now I would want Guru to rest for a minute. Let me see if I can take someone else before I'm I'm accused of partiality. Thank you so much, Guru. Be on standby. If we need to, we'll get back.
You're welcome.
Thank you. Mary Upon there, please put up read for me. Afterwards, I see some few other hands. You all read. Go ahead, Mary.
Note. Degree of confirmability.
Yes.
Statistical hypotheses are easy to confirm than law-like hypotheses.
Easier. Thank you. But it's easier. We are doing a comparison. Okay, so it's easier to confirm than law-like hypothesis. Very good. we don't struggle to make statistical hypothesis true. That's confirm. Confirm means true. I'm making it true. If you were comparing it with law-like hypothesis, a comparative study. So I may be taller than Mary. She might taller than may be in relation to Mary. I may be taller than Mary. But perhaps if I was compared to Guru, then I may be shorter. Get it? Because of the nature of the questions we ask you. If it's a relational question, don't go thinking that you have not gone to someone's farm. You think you are the only one who has plantain. you make mistakes in the way you are reasoning. So I'm saying that if you are comparing statistical hypothesis, now you know it, with a law-like one. So if I'm saying most women cheat, and I'm comparing that to all women cheat, then the statement most women cheat, which is statistical hypothesis, will be easier to make true if you compared it to what? All women cheat. Why? Because of the empirical content, the reference class, the subject which we have known over and over again, because of the magnitude, the size of the reference class. If it has a very big reference class, like that is, for example, if it is law-like hypothesis, it will be very easy to make that kind of statement false. Okay? And the one that is easier to make false will be more valuable to the empirical scientist than the statistical hypothesis, which is easier to make true. That is what my sister is reading on the screen, and I've concluded for her. Sister, read, why falsifiability is valuable to the empirical scientist. Now we want to hit at it. Why would a discipline value or cherish theories that can easily be made false than others that can easily be made true? There's a reason. Go ahead.
When a theory is falsified, then the
Hey,
empirical
sister, you
scientist
are designer power. Please read it assertively, okay? Some people struggle to hear when we play back. Why? So read it strongly, like in the United Nations Secretary General giving a speech. Go ahead.
when a theory is falsified, then the empirical scientist can be certain that it's not true.
Mhm.
And two, that when a theory is confirmed, it only means that there is currently evidence that
Corroborates the likelihood of the theory being true. Okay. Now, let me explain that. So, if the scientist is looking for certainty, that is the heartbeat of the scientist, trying to understand the world that he or she didn't create, to help him or her predict and help us live until we are called home. You see, the meteorologist, for example, wants to know if tomorrow it will rain or it will not rain. The economist is trying to interpret how human beings are behaving in terms of resources. The political scientist is trying to get into the minds of people in terms of who they want to rule or organize human society for them with their permission. These folks are all trying to understand the world. So when we go to the physical sciences, it's even better. The heartbeat then is to know the world, whether it's physical science, social science, or the one that we call what? Human science, psychology, etc. Now, every empirical scientist is trying to achieve certainty. He's looking for something that can be known for certain without doubt. But the world that he or she is investigating was not created by him or her. And the findings are observation-based, like I said earlier. So if you give me more evidences that support what I already have discovered, you haven't helped me too much. I already have discovered that women who get pregnant deliver in 9 months' time. Then you bring me more evidence of such women. Oh, this one to give birth in 9 months. Oh, she also gave birth in 9 months. What that does is it increases the likelihood. That's what Madam read. that our finding may be true. But we are never able to confidently say that it is absolutely, certainly true. That we can't do that. No matter the number of evidences of people who deliver in 9 months that you bring. Because then we are still worried that potentially there could be a child that will be delivered in 7 months or 6 months or 10 months or 12 months. Now, as you and I speak, that has been falsified. We have babies that at 7 months, they don't want to stay in the tummy again. They want to come out. You can't ask them to remain there, that they are going to break a law. Remember Unit 5, natural laws, scientific laws can be broken because that law itself is just a prediction based on your observation so far. Then you predict that, oh, then this one will be like that. So the meteorologist thinks that it's a prediction, an informed one at that. Okay. Therefore, so what? So if we find a theory that is prone to falsification, a general claim that you can easily make false, like what? All metals expand when heated. All women deliver in 9 months. Anytime the class gather each way, all these have done that. Universal statement. If we found that, we prepared our theories that way, then for so long, it hasn't been falsified. Remember, if you have a universal generalization like that, you just need just one counterfactual, one opposite. It will make the whole thing false. We don't care how plenty evidences that supported it. Just one counterfactual will negate the whole thing. So you have made your theory so law-like, so universal for many years, and you still haven't discovered just one counterfactual to it, then your degree of certainty is increased. Can you see that? Yes. Now, if it turns out that one day you discover just one metal that will not expand when heated, the scientist's theory is falsified. But you will be amazed that that day they will do party, the scientific revolution. There's joy. The scientist is not doing church. He's not doing dogma. He's not afraid for his theories to be falsified. If he is properly doing genuine empirical science, a falsification is a victory. Why? Because then you will know something for certain now, certainty. What is that thing? That asumua, not all metals will expand when heated. Not knowing all metals won't expand when heated. At least there is one. You find out that when a universal statement is negated, in other words, we find a counterfactual, science rather progresses. Those of you doing science, the College of Health Science today, that is when you see that people are busy. Hey, we have a then for COVID-19 or something else. We have a supposed, with what we thought we knew is there's a scientific revolution. Our planets are no longer whatever number. Now I don't even know how many we have, 12 or 11 or 9 or 8, or still counting. Some say we have thousands. Now, it brings a revolution. If you should find a metal that will not expand when heated, or a planet that will not orbit the sun, you see how all research will go into that, because we have found something, take note, that we can know for certain. That is what? That not all metals expand when heated after all. That not all women deliver in 9 months. So the negation rather leads us closer to what? Certainty. Negation of falsifiability gives us what? Certainty, which is what he's looking for. So either way, the scientist will gain when he or she presents his theories as what? Generalizations. If it hasn't been falsified for him or her to get certainty, what will be happening? The fact that the thing is a universal statement that needs only one thing to make it false, but has still not found that one thing for many, many years of study, gives a certain degree of confidence in that theory. Like, for example, metals expand when heated. Okay? Then if it turns out that one day it finally gets falsified, still, even the joy is more perfected, because then now we know for certain that not all metals expand when heated. What have I tried to explain? To show you why the falsifiable statement, the higher the degree of falsifiability, watch, I'm going there now. We're almost done. Why the higher the degree of falsifiability, the more valuable a statement is to the scientists. because then such a statement will have a higher predictive power. Look on your screen, I projected something. It will predict more. If I say all metals expand when heated, you know something about all metals. If I say all water is a good conductor of electricity, then in your room, when you see that it has rained, the electrical cables are falling into the water, and some sister is coming out of her car to step into that flooding, you will shout and give prophetic word. Sister, don't come out of the car. You are going to be obituary, skeletons, bones. You'll be saying that because you can see by what you know so far about metals. I said all metals, all water is a good conductor of electricity. So you're able to predict what will happen if she came out of the car. All water, it gives you predictive power. That means the general statement, the universal type, has more value to the scientist, has a higher predictive power. See the connection? Has more empirical content. Reference class is saying more. Easier to falsify than if you compare that kind of statement to the statistical one. And then the statistical one has all of these than the verifiable statement. See the relation now, it's comparative superlative. So all women are cheats. It's more valuable to the scientist than most women are cheats. And most women are cheat will be more valuable to the scientist than that woman is a cheat. In that order, okay? That is what I'll summarize over there on your slide 21. Look at it. So first is universal generalization, followed by the statistical one, and then verifiable one. What we hate as scientists is a statement, my friends, that has no empirical content, is pretending to be science when it is not. Look on our screen. A scientific statement from all that we have said then is a statement that is what? Falsifiable, able to be false. Whether it is general or particular, we don't care. But it should be possible for the statement to be false. That is why it is testable. We go and test it to tell whether it is true or false, actually speaking. So when you give us statements that are not possibly true or false, it doesn't have the capacity to be false, it is not scientific. It's dogma. We do that at church. When I say church, when we are working with what? Prescriptions that cannot change, you see? But in empirical study, we give theories that could be false. So the principle of falsifiability is what makes it scientific. If it is a scientific statement, it should be testable, should be falsifiable. So whether verifiable statement or confirmable statement, it is scientific because it's testable or falsifiable. Now, if I tell you tomorrow it will rain or it will not rain, like I said in the recorded lecture, that is necessarily true, even if tomorrow doesn't come. Because when tomorrow comes and it rains, what I said is true. When tomorrow comes and it doesn't rain, what I said is still true. You will give birth to a child or you will not give birth to a child. That is necessarily true, even if you never give birth. Because of the nature of the statement, a statement or its negation. Any statement that has that posturing is pseudo-scientific. It's pretending to be scientific. It will never be false. No matter what the evidence out there shows, it will make it true. It's necessarily true. It's tautology. We describe such statements as what? Pseudo-scientific. Because they are pretending to be testable. But when you look at the way the person spoke, it will always be true, regardless of what happens by observation. The scientist doesn't admit that. We call that pseudo-scientific statements. Okay? And I want you to be minded when you see one. Then on our screen now, I think I should take some answers from you just to warm you up. We are finishing. You have 2 slides to go. So see on the screen, we are comparing degrees of falsifiability, empirical content, predictive power, scientific value. In all of these instances, what do you look at? Reference class, finished. So look on our screen now. First statement says the Earth's orbit around the sun is elliptical. The Earth's going around the sun, okay? You see the Earth's orbit around the sun is elliptical. Look at the second one. It says all the planets that were discovered by Kepler before 1620 AD have elliptical orbit. This is D2 from your textbook. I just pulled them out and put them here for you. The third one, all planets have elliptical orbits. We are going to compare the degree of falsifiability, empirical content, predictive power, scientific value. So suppose I asked you, oh dear, keep that thing muted, my dear friends. Which one of the three on your screen, these three statements, which one has the highest empirical content? Is it 1, 2, or 3? All of us.
2.
3.
3. 3.
Is it 1, 2, or 3? All of us, please.
Number 3.
Number 3.
3.
Number 3. Very good.
Yes, number 3.
Okay, the next question.
Number
Which one
3,
has the the next one? Hold on. Which one has the highest empirical content? If we were comparing, listen, hey, my brother, you have such a background, then don't open your thing. If we were comparing only 1 and 2, listen to my question very well. If we're comparing only 1 and 2, then which will have the highest empirical content?
2.
2.
Very good.
2.
Because
Number
1.
3.
thank you. Because for us, 1 is talking about only one planet. Listen, because 1, example 1 is only talking about the Earth, one planet. But example 2 says all the planets. It could be 2, 3, 4, 5, or whatever. Even if there were only 2 in this reference, all the planets is not the same as the Earth. The Earth is just 1. So the content, the reference class in example 1 is just 1 planet like this. Whereas in example 2, we have more than 1. So even though the 2 examples are both particular statements, one has more empirical content than the other. And so all the discussions we've had so far will apply. One of them will have more predictive power than the other. One will be scientifically more valuable than the other. One will have what's the other thing? A higher degree of falsifiability than the other, and so on and so forth. So how do you choose it? First, the universal statement. Then the next one of value will be what? The statistical one. And then the last one will be the verifiable one. In the examples I gave you on the screen, this one, there is no statistical statement there. You can see. It was just 2 particular statements and then a universal one, the third one. I could have put in a statistical one. Your textbook gave you, I think there were 8 or 9 in all, and you were asked to apply an answer. Which one has the highest degree of falsifiability? Which one is easier to make true? Which one is easier to make false? Take note that the higher, where is it? I'll repeat it again. Here is it. A valuable empirical information must be falsifiable to be what? Scientific. A statement that is not falsifiable cannot be verifiable or confirmable statement. This is referring to pseudoscientific statement, okay? A statement that is absolutely true has no empirical content. It's a pseudoscientific statement. If it's a tautologous statement, it is pseudoscientific. Okay, so what? So until read this, then we are so done. I can take questions. Let me take Millicent Adomako. Thank you, Mary. Millicent Adomako, read what is on the screen. It's a summation of everything said. Then we'll see if there are questions. We'll take them. Go ahead.
Okay. Empirical content, degrees of falsifiability and predictive power. The more general a statement is, the more empirical content it has. The more empirical content a statement has, the higher its predictive power. The more predictive power a statement has, the easier it is to falsify. The easier it is to falsify a statement, the more valuable it is to the scientist.
Excellently read. That is the summation of everything. Remember that it was our sister Adomako that read it. And she read it very well. There's no ambiguity there. That slide alone, my dear friends, can make or make someone. So I want people to take note. It sums everything that we said in the unit so far. It helps you realize that, look at the practice, this thing there. There's a slide I put there just to help you. I said try. So I gave, this is a past question from some part-time somewhere. See, heavy smokers are prone to cancer. That is A. Possible answer A. Then possible answer B. Most heavy smokers are prone to cancer. Then possible answer C. That heavy smoker is prone to cancer. And then possible answer D. Either that heavy smoker is prone to cancer or he's not. If you did you engage the class, even today's old very well, then you see that is a general statement of a particular one. I want a uniform answer, please.
A general.
General.
General statement. Which type of generalization is it?
Universal.
Universal.
Universal. Very good. So universal generalization. If you don't see universal, hey, my friend, your background is not good. Don't open yours. If you don't see universal, you could also see law-like generalization, and it's the same thing. Okay, how about the second one? We can all tell that the second example, most heavy smokers are prone to cancer, is a statistical generalization. It's still a general statement, but a statistical one.
Universal.
Yes. The A is universal, yes. The B is statistical. Then the C is a verifiable. You have people. Some people are using earphones. I beg you. If the thing is too noisy, then they don't
is
benefit.
particular.
Please, okay. Some have a quiet background, so sometimes when they interrupt, I don't get at them. But if you have a very noisy background, it's not fair. People have ear issues. You can disturb them. Why? So keep your thing muted. Even if I say chorus answer, you know that you are the market. You are multitasking. No problem. But don't don't let us all hear the trotro there. Why? So we are finishing. I want you to get it. Then the C is particular, that heavy smoker. D is not stating anything that is scientifically valuable. It is empty of empirical content. Look at what it said. Either that heavy smoker is prone to cancer or he is not prone to cancer. This is a tautologous statement. It's necessarily true. If you go and he's prone to cancer, it's true. If he's not prone to cancer, it is still true. Okay, so it's a pseudo. If you got that, then you see that you know all your answers. So I'll quickly walk you through that. I have to really rest before the next class. See, which of the following has the least predictive power? Look at the expression least. It has predictive power, but it is so small. Which one would it be?
A.
You may think of it. Oh, A, least small one. Sorry.
C.
It will be which one?
C.
I think it will be C. You see, there's a little more confusion in the textbook sometimes. Okay? Because the textbook wants to say that even verifiable statements don't have empirical content.
Because it is pointing to
I'm coming. I'm trying to point up. Oh dear. I'm trying to point up a certain confusion that you can have. So listen, please, okay? In your textbook, some portions would want to even think of verifiable statement as empty of empirical content. That is a seeming confusion. But if you had these possible answers here, okay, look at it. And I gave you A, B, C, or D, and I asked you to exclusively pick one answer. Then it will be the one that has the least predictive power, I'm thinking should be C, where it is a verifiable statement. Because even if it's verifiable, it gives you some content. It's just that the content is specific to that particular group, okay? For example, if I said all the metals expand when heated, I'll be speaking to you about the metals in question. So it doesn't have so much information, but there's still some information. So I want you to be minded when you see the one in the textbook, so you don't get confused. So we'll choose C. That heavy smoker is prone to cancer is giving you the smallest level of what information if you compared it to the B and the A. Least means small. Okay. How about the one that has the most empirical content? What will we all go for? A, B, or C, please?
D, D.
People are saying J. People are saying J. I heard
Heavy smokers are
Don't be
prone
able
to
to put
cancer.
together. Okay.
Heavy.
Very good.
A.
Okay, that's fine. So I've heard you.
Apple.
Let's
A
move on.
for
Thank you. Yes, A for apple helps. Now let's see the third one.
It's A.
Thank you. You are going to the third one, which is or a pseudoscientific. I would choose the pseudoscientific is a straightforward D for Daniel. Can you see that?
D. Yes, D.
Yeah, D,
Okay.
D for
It's okay.
Daniel.
Thank you. Let's go to example 4. Me now, I want to answer answers. Now I'm even tired. It's okay. Now let's go to the fourth one. I want to help some. It will help their revision. 4, which is easiest to falsify? A, B, C, or D?
B.
A for apple. I hope you can see that.
Yes.
A for apple is the easiest to falsify. Why? Because it has the highest reference class. It is A that has the highest reference class. Why do we say it has the highest reference class? Please, I just disabled all the mics. I'm sorry. I'm wrapping up so that people can get concrete conclusions. Why do we say that the A has the highest reference class? Look, it says heavy smokers. We already diagnosed our option. This is universal generalization. Then B is statistical generalization. Then C is not even a generalization at all. It's a verifiable statement. And D is not even a scientific statement. It's not testable at all. That's the degree. So if you ask me which is easiest to falsify, I'll go for A. It's a universal generalization. Then if you say which is or are directly testable, there is only one that is directly testable. Don't mind the is or are, it's to confuse you. C, it is only C that is a verifiable statement. Okay. Which would you call verifiable? C, we just did that. Which is absolutely true regardless. That would be D. D is a tautology. Okay. So D is absolutely true. It doesn't have any falsehood in it. That's why we throw it out if we are doing science. They're not doing dogma. Then which is tautologous? It will still be D for Daniel. It's a tautology. It's just another way of saying pseudoscientific or absolutely true. We said what? And therefore empty of empirical content. Then 9, which would you call hypothetical or confirmable? I want an answer for that. Let me unmute you. Which of them, or which would you call, where is my thing? Which would you say is hypothetical or confirmable? I want a uniform answer. But if your background is noisy, please don't unmute. Okay.
A.
Only A.
Madam A.
Hypothetical
C.
and confirmable.
I'll go for C as confirmable.
A and what?
And B.
A and B. Can you see that?
A.
Okay. Now let me help those who may not have seen it. Don't unmute now. Okay. Thank you, Abdul Karbu. Now keep it muted. Listen, those who may not have seen the point, I said that if I allowed you to choose this question, if I say which of them is confirmable, heavy smokers are prone to cancer. It's a universal generalization, it's confirmable. But most heavy smokers are also prone to cancer, It's also confirmable. So here, the options will be A and B by the very question. Where is it? Which would you call hypothetical or confirmable? I'll choose A and B without any ambiguity. Okay. When we chose which of them is empty of empirical content, we said the obvious answer is D. But because of the comment made in your textbook, you may want to include C, which is not exactly correct, if you ask me, because even the verifiable statement is still making a claim of content. It's just that the reference class is small. Okay, so the typical answer I would have chosen for that is a question offended. Question 5. This is question 5, which is or are directly testable. That one is not in contention. Which would you call verifiable? That one. Which one has the least predictive power? I'll choose C, that ambiguity. But we got to example 9. There you have to choose 2 answers. It's not optional. Don't have an ambiguity there. It's a clear-cut answer. What was the question for 9? It said, which would you call hypothetical or confirmable? That one is A and B. And the last one, which will you use as evidence or data or observation statement? I would use C, because that one is verified. You see that? Yes. But someone may use a statistical hypothesis. We already showed you what the problem could be with that one. If your evidence is itself pregnant and needs to be verified, then it cannot help. It cannot be a very good working tool as what? An evidence. Very good. So for question 10, the good choice will be C for cat. And on that note, we were finished and we came back and we were finished and we have finally finished to finish. This is just for your preparation. What you see on your screen. So note that you have covered 1, 2, 3, 5, 6, and 7. Unit 6 and 7 will do your short answer component. That carries 10 marks. And then unit 1, 2, 3, and 5 will do your multiple choice component, totaling 30%. Study the lecture resources, slides, videos, question and answer sessions, etc., along with the prescribed textbook. Emphasized. Practice exercises the textbook and tutorial among yourselves, and go to the center as prescribed, and you do excellently. I want to take questions. Thank you so much. Simon Ahifia, is there a question? Abdul Kabir, is there a question? Your hand is up. Irama Dobe, is there a question? Oh, I'm so sorry. Don't worry. We'll meet again for unit 9 after your IE. Okay, then you get to read. The Clement's hand is up. Nafisa, are they all readings? Okay, so I see 4 hands
Madam.
up. If any of them is a question, please go ahead.
No, madam.
Okay.
I wanted to ask.
I'm listening, Nafisa. Go ahead.
I wanted to ask if pseudo is the same as, or can be said to be tautology.
Yes, we said that. Yes.
Oh, okay.
Yes.
Thank you.
When you make a tautological statement, it will be pseudoscientific. Yeah. You, Clement, please, is it your question? Amadou, is yours a question? Okay, yes, so I see 3 hands now. Please, I'm waiting. So if it's a question, just unmute and ask so I can wrap up nicely. Then we are done.
Madam, please, I want to find out, is it possible that a particular statement can be confirmable in a general statement?
Is it possible for a particular statement to do what, Amadou?
To be confirmed.
Oh, I can't hear the rest. To be what?
Confirmable.
Please, if someone heard Amadou Taibatu, please.
Confirmable. Confirmable.
You say, is it possible for a particular statement to be confirmable?
Yes.
A general statement.
That's what we said.
Yes.
And my brother, I can hear you clearly. So repeat what she asked for me, so that I can hear.
She was saying, is it possible for a general statement to be confirmable?
Now that's what we've said, though, and we said that general statements are confirmable. My dear
Yes.
Amadou. That's what we said. Okay, you don't worry, my lady. We'll bring you the recording. So when you play back, even the slide said explicitly, raw notes like that. When you look at it, PDF, very light, not heavy. It states there that all confirmable statements, all general statements. Right? Okay, my lady. Is there a question? She has a question too.
Yes.
Please go ahead.
Please, about the IE, we don't know the date. And
please be careful with we don't know that. I hate that thing with every venom in my you are who don't, my brother.
Madam, sorry, I don't know the date. I'm sorry.
Why don't you know the date?
Madam, please, I'm sorry. I don't know the
student. Hold on, number. Class, please answer. Then we seal our session with this. Is there notice on
I think it's
data?
Yes.
Check your email. Check your
Madam, it
email.
is there.
Yes, have a wonderful week, everyone. Now we'll go to the concert before I get angry. If you miss the IA, you lose the
Madam, we don't have the two minutes. Have a great day. It is there.
I've told you, go and look for
Check your
the
email if you don't have data.
Right, have a wonderful week. All the best and take care. You don't have
All right,
data.
bye, madam.
Take care.
Students, right? So what do you do if you don't have data?